Alright, so today we'll go over one of the examples in chapter 25, and I'm going to explain the skills on JMP that you need to get results of the examples in the book. So the data that are actually being used for these examples are right here. So we're checking salaries of managers of Walmart. We have information about their years of experience. We know how many of them are male or female, so we have their sex, and we have the group. So we recoded sex, male to 1, female to 0. I'm going to show you how to create that dummy variable, which is here. And we also can, one part of the example we're going to talk about those who have 5 years of experience and compare them based on sex, which is male versus female. So to run all of these analysis, I'm going to use this data, and this data is available on files, the folder data. Okay, so going through this example, the first thing we see is a two sample comparison, and we have separated the groups of male and female data of managers, information of managers, right? So to create a comparison, we have two samples, we use t-test, right? So go to fit y by x, and you are trying to see if there's a significant difference between, there's a significant difference between male and female regarding salary. Okay, sex affecting salary. And look, that's the same, right? You want to create that box plot. It's not difficult. You just red triangle, you go down to I think it has to be down here on display options and have a box plot, and that's the same box plots, right? If you stretch this a little, it's going to be exactly the same. And then let's see what test should I run. So the book explains that the type of the t-test that the book is using, if you read the book carefully, it says that it's using the pooled t. Okay, so we use means. We want to see the difference between the means using the pooled t. That's a t-test. Just uses different formula. So these are exact same results that you are going to have in the book. So look at the 4.67. Standard error of difference 1.98, 1.98, right? And in confidence level, upper 95, lower 95, 8.5, 8.5, 0.75, 0.75. So these are exactly the same, right? So that's how you get it. And then because the confidence level, they're both positive, there's a significant difference here, right? But we learned in these chapters that there is a confounding variable. That means there is another variable that it actually has effect on the results, and if we don't take it into account, that's a problem. So that's where analysis of covariance comes in. You have a categorical variable with two groups like sex affecting salary, and you want to compare the groups of male and female, but there's another variable, confounding variable involved, like years of experience, and years of experience is continuous. So years of experience as a continuous variable, if it's added to this analysis, it's called covariant, right? And this covariant is additional IV. So you already have one IV, sex. You're adding another IV, which is a covariant. So this analysis is called analysis of covariance. Okay, so that's what we call it ANCOVA. And we have actually practiced this before, but not in the details that we're going to do it right now. So here we can see that these are the same numbers we had before. We just had it right now. 4, 6, 7. And why is it decimal and here it's not decimal? Here's in dollars. Because the data that we have, do you see up here it says 000? The data is in $1,000. Up here it says in $1,000. So multiply that 4.67 by 1,000, that give you 4,670. So how about for 5 years of experience? How about for 5 years of experience? So what I can do to check that probably is I can again go to fit y by x and get sex as IV, salary as DV, and now this time I want to add or consider 5 years experience. Those who have 5 years of experience. That's 5 years, right? 5 years of experience. I put it under by. So we're comparing, but this time we're comparing by 5 years. And I'm using the fit y by x at this time. Just want to compare when 5 years is controlling and when it's not controlling. So when it's controlling, you can see that you have two separate results. When 5 years is dot, that means those that they're not 5 years, those that they're exactly 5 years. They have 5 years experience. So for the 5 year experience, I click on the red triangle and again perform a means ANOVA pool T. What actually that can give me is same results as you can see here, 378. What is this number? The difference between the male and female's salaries in average, right? Average salary of male and female. The difference of all managers is $4,600, $670. But the average of only managers that have 5 year experience is 378. What does that indicate? That's telling us that probably if we consider years of experience into account, the difference between managers' salary is not actually that much different, right? And that's helping us statistically saying that, hey, male and female managers are actually getting paid pretty much the same. And the difference is very small. And we're not saying male managers are having more or less. This could be for some years it could be male, for some years it could be female managers. So it really depends on how many years experience. I believe in the book you will see that it says female managers in a higher level of years of experience, they actually get paid higher. So if they're saying there's a discrimination going on, that could be because of a wrong analysis. And a better analysis can be including a confounding variable like years of experience into comparing male to female. Okay, so you can see that the same results are here, 378. Again, these dollars are in $1,000, so you multiply all numbers by 1,000. And difference is the standard error of difference is 4.26. That's correct, 4.26. Upper and lower confidence level are the same. You just need to multiply them by 1,000 to get in dollars, right? And that's it. So that was this part. So we're comparing using fit y by x at this point. So the next analysis in the book is actually explaining analysis of covariance. So what's the difference between the analysis of covariance and the comparison we did using the pool t-test? The difference is in analysis of covariance, other than just adding years of experience and sex, we also want to see a combination of these two variables, right? In the interaction of years of experience and male and female. So what the book explains here is that looking at the regression formula of the analysis of covariance. So analysis of covariance is a type of multiple regression where one of the variables is a group variable, right, or a dummy variable. So you can see that female is in red. The slope of the line is actually moving faster. That means female managers, when they have more experience, their salary is actually increasing faster. The starting point is lower. Female managers who are hired at the beginning, in average they get paid lower, but in long term, when they are having more experience, they actually earn higher salary. So you can see that years of experience actually is explaining the difference, and you can see that in average the difference is not that much, right? So let's see how we get these numbers. So to get these numbers, we need the analysis of covariance, and we just need to, let me see if I have, yeah, I have these, right? And for that part, I need, we also use the fit y by x, and use salary as a DV, and use years of experience as our IV. And we want to control this using sex, right? By sex. And press OK. So you can see that we have both. This is for female. This one is for male. So separately we are creating male versus female. So this is not the combination, okay? Not the combination yet, not the covariance yet, but actually comparing separately. So we have, we can check the fit line for both, fit line, and the fit line for this one as well. And you see that we are comparing the R-squares, standard errors, and the slopes, right? So we can check that here and see if we get the same results here or not. See, if you round this number, that's 1.39 approximately, 1.39. I'm sorry, 0.139, 0.139 or R square for the female, and that's a female. Standard error is 11.25, 11.225. That's pretty much correct. And 130 plus 1.17, 130 plus 1.17. So these are correct. And p-values are also correct. So how about for male? Scroll down for male and you can actually see. For male we have 0.09. For the R square we have a standard error of 12, and we have also, let me see, the intercept is 135, intercept is 135.6, and the slope of years of experience is 0.76, right? So these are pretty much the same, right? Just rounded. In the book it's rounded, on JMP it's not rounded. So if there's any question in the book that you want to compare numbers, get these numbers out, you learned how to do it right now, okay? Alright, so next we'll be combining the regressions. So in combining the regressions, men and women require a dummy variable. So one of the students actually last time asked me, okay, how do we create these dummy variables if they're not given? I believe they have to be given. And look, when you have a male manager, we put a 1. When we have a female manager, we put a 0. So now the question is, how do we transform male and female to 1 and 0? Right, you can click on the red triangle here on the column and click on a new column, or you can, on the right hand side of the bars, find space here where we have a column empty here. Right click and click on a new column, and that new column you can actually put a name. In that example in the book, its name is group, so I put group dummy. So I'm going to change male to 1 and female to 0. Click on column properties and click on formula. So that gives you the option to create a formula here. And we are going to use conditional if sex. So I click on if under conditional. I click on sex, sex appears here. If sex, and I just type equal one time. You one time click equal, that double equal sign means that sex is the value of male, right? So you want to type male here. Just type male. So if you don't do that, you will receive an error. So press enter. If sex is male, the value given to sex is 1. Else means in female. If you have more groups, you can also change that to 0. For any other group, it's going to give you a 0. Alright, so click apply and click OK. And that's it. You just click OK. And you can see group dummy, 1 for males, the first 3 are male, the next 2 are female, and that is actually create. So the other part is asking you to create the combination of group and years. So how do you do that? So let me just put it right here. Do you see that for male, group is 1, 1, 1. So you just multiply years of experience. You just need to multiply the years of experience times the group. If it's 1, the same number appears because you are multiplying by 1, so 16.7. If it's a female, we put 0 as a code for female, right? So 13.9 times 0 is 0, right? In this way, we are separating these two. So slopes of male will appear, slopes of female will not appear in one analysis, and for female we can redo it again. So that's how we create it. Where do we create that? Again, under the red triangle, the same process. You just type maybe group times year, or maybe years, I think years, group times years, okay? And on formula, you just create the same formula. Create a formula that it multiplies. We already created the group, which is the dummy variable, and just click on the multiplication and then click on years of experience, and it should work. Group times years, right? So that's the same thing. So 0 for female and years of experience for male. And as a result, we have this ready, and let's go to the analysis. So now that we have the group by years, we can run analysis of covariance explained in the book. Okay. So let's go back to our results here and see what we have. So that's the calculation explained here. And for this part, for the combination, we can, after creating your you're going to use the fit model or the model fit, and then salary is still your DV, And your IV is going to be, one of them is group, right? If see here, years, so let's put years first. And then we have group, and then we have, so we have years, we have groups, and then the combination, which is, we just created it, right? Let's use this one. That's the multiplication of the two, or the interaction. And I believe that's it. You just click run. So I don't want all of these. Let's reduce this.
Do we do minimal report?
Yes. If you do minimal report, you won't see those extra things. Okay. Extra. These are actually not really extra. It's just different slopes for male versus female. Okay. But that's not what we need. We need results down here. So do you see these results? And they are actually pretty much the same. So 130 years of experience, 1.176, group 4.6, and negative 0.415. And the p-values are the same, right? R square 0.135, standard error 11.7. And so up to this point is just what you get on JMP to get the ANCOVA results for our MyLab problems. But the next step will be checking conditions. So for checking conditions, this is actually exactly the same as multiple regression that we did before. You can create your upper or lower bound on columns, 95% upper lower, and you can also check your VIF under column. Same things that you check there, you need to check here, because this is a multiple regression, right? So in fact, it's a multiple regression. Row diagnostics, you can check the Watson test. You can also check plot residuals by predicted is already here. So you can see that it looks like a circular, right? I told you if it's a circular or if it's like a rectangle, symmetrical on both sides. This is showing similarity of variances. And this model is quite significant. But we can see that there is a high, the group by years, the VIF is 13, is higher than 10. So this is suggesting we probably need to remove this to create a, so we have a collinearity problem here based on VIF, right? Because high VIF means there is a collinearity problem, high correlation between IVs. So this is not acceptable. So what I'm going to do, go back up here and just click on group by years and remove it. And that changes the results, of course. And look, this should be in the book as well. It shows that's the estimated salary predicted by residuals. And down here, let's see if we have this. This is the VIF 13 that I just showed you. And I showed you that we removed it, right? It doesn't have the results, but after removing, this is another example. So after removing, you don't have that amount anymore. You have a better model, more significant model.